Good morning, ma'am. Myself Praveena. I'm from Triple department. My topic is about explain heat sink design, ferrite beads, filtering, and PCB grounding used in EV and SMPS design. My roll number is 234G1A0282. I'm explaining about the heat sink design, ferrite bed filtering, and PCB grounding used in electric vehicles and SMPS. In this, EVS is referred to electric vehicles and SMPS is referred to switched mode power supplies. These are the required efficient thermal and electromagnetic management. These are the proper design with ensure reliability, safety and optimal performance of electronic components. This presentation covers heatsink design, ferrite bead filtering and PCB grounding techniques used in these systems. Importance of thermal management and electric vehicles and switch mode power supplies. In these are the critical to prevent component failure and extend device lifespan. These are the main include thermal solutions, heat sinks, fans and thermal interface materials. Fundamentals of heat sink design. Heat sinks are passive components that dissipate heat from electronic devices to the environment. They operate by increasing the surface area in contact with ambient air. Proper design. These are material choice, fin geometry, airflow for optical performance. Materials used in this heat sink design. Cost effective, lightweight in these aluminum, copper. These are the superior thermal performance. Aluminum and copper are the most common materials due to high thermal conductivity. Material selection depends upon the power dissipation and weight constraints of the application. Heatsink geometry and fin design. Fin shape, size and safe spacing influence that heat sink's ability to dissipate heat. Fins should be designed to maximize surface area while minimizing airflow resistance. Fin density must balance between heat dissipation efficiency and manufacturing complexity. Heatsink attachment and thermal interface material. Proper mounting ensures good thermal contact between the heat source and the heatsink. Thermal interference materials like thermal paste or pads fill gaps and improve heat transfer. Ferrite beads for filtering in electric vehicles and switch mode power supplies. Ferrite beads are passive electronic components used in to suppress high frequency noise, high impedance, unwanted signals, reducing electromagnetic interference. Working principle of ferrite beads. Ferrite beads operate by dissipating high frequency energy as heat through magnetic properties. They are very effective in filtering out RF noise in powder and signal lines. Their impedance varies with frequency, providing targeted noise suppression. Selecting ferrite beads for electric vehicles and switching mode powered supply application. Selection depends on the frequency range of noise to be filtered and current ratings. Low DC resistance is preferred to reduce power loss. DC resistance is low to reduce the power loss. Compatibility with the system voltage and thermal environment is also essential. Implementation of ferrite beads in circuit design. Ferrite beads should be placed close to noise sources such as switching regulators. They are typically used in series with power lines or signal lines. Proper layout minimizes parasitic inductance and maximizes filtering effectiveness. PCB grounding strategies in electric vehicles and switch mode powered supplies. Effective grounding minimizes electromagnetic interference and ensures safety. Multiple ground panels can be used to separate noise and sensitive circuits. Proper ground rotating reduces ground loops and voltage differentials. Types of grounding configurations. These are the two types: single point grounding connect and multi point grounding connect. These single point grounding connect at common point to reduce loops. In this multiple point grounding connects at multiple points for distributed noise control. The choice depends on the system size, complexity, and electromagnetic environment. Best practices for PCB grounding: keep high current and noisy traces away from sensitive analog grounds. Use solids continuous ground panels to reduce impedance and improve shielding. Ensure low inductance ground connections for critical components. Grounding and shielding in EVS and SMPS system. Proper shielding prevents external electromagnetic interference from affecting operation. Grounding shields to the chassis and at the ground enhances safety and noise reduction. Isolating sensitive circuits from high current line minimizes interference coupling. Common grounding mistakes and how to avoid them. Creating ground loops that can induce noise and cause measurement errors. Overlooking the importance of proper grounding in high frequency switching circuits. Integration of heatsink, ferrite beads, and grounding. Adequate heat sinking prevents thermal issues that could compromise filtering components. Future trends in electric vehicles and switching mode power supply design. Advanced materials, innovative heatsink geometries improve thermal management. Integrated PCB grounding techniques continue to evolve for better electromagnetic compatibility. Thank you for giving this opportunity.